All right, this is page 3 of the second semester final review packet. So number 20, which of the following molecules would be harder to boil? Circle and explain why. This one, definitely, because if you look at this one, it's non-polar, which means that if you had another molecule of its same type right next to it here, they don't care about each other. There's only a weak intermolecular force holding them together. It's easily broken, so they can get free and boil and move away. This one, however, if you notice, it's got this oxygen here, which would be pulling on the carbon and the hydrogen, and it would be partially negative, causing these two to have a partial positive charge. So this is very polar. So another molecule that was right next to this one, the oxygen of it would be attracted to maybe the hydrogen, for example. And so these have hydrogen bonding forces between each other, which are much stronger than dispersion forces. So these would be much harder to boil. Number 21 switches gears into Unit 4. It says balance and identify the types of reactions. So let's just do the types first. You notice on the first one, it's a bunch of carbons and hydrogens plus oxygen forming carbon dioxide and water. Every time you see that pattern, you should know that is a combustion reaction. Versus something like letter B, there's one thing being added to a compound. So this one thing is going to try and kick out the other, since this is a metal, it's going to kick the metal out. So this is a single displacement or replacement. It doesn't matter, they both mean the same thing. Finally, we've got one thing breaking down into two things here. That would be decomposition, which makes sense. Something that's decomposing is breaking down. And down here we have two things adding together to form one thing. That's called a combination reaction. So there's only one type of reaction that's not pictured here, and that's a double displacement, when you've got two things being added to two things. So a compound being added to another compound, and the first two things switch places. Now let's do a little review of balancing reactions. If you only see carbons, hydrogens, and oxygens, you use the Cho method. So first balance the C's. C3, so you need 3 C's there. H8, so you need a 4 here to make 8 H's. How many oxygens on the right side? There's 6 plus another 4. That makes 10 oxygens, so we need a 5 here. And you can fill in a 1 or you don't have to. But now we're balanced. How about letter B? Check this out. We've got Fe3N2. So let's try putting a 2 here. So we've got 2 N's on the right. Fe3, we need a 3 there. Now we've got 2 Als, so we need to add a 2 out front here. How about letter C? H2O2, and then we've got 1 O here and 2 O's there. So we know we need to create more O's, so at least we've got an even number. So now we've got 4 O's, so we need a 2 here. 2 times 2, that's 4 O's plus the 4 hydrogens. Everything balances out now. How about the last one, MgO, and on this side it's O2. So we need a 2 out front to make it 2 O's, which now we created 2 Mg's, so we need a 2 there as well. Then we take it up a notch in number 22, because after we predict the products, then we're going to balance the reactions. So this is one thing trying to kick out one thing. And how do you know which it's going to try to kick out, the Li or the Cl? Well, you need to refer to your activity series. Notice here that Li is on the metals side. Metals can only kick out other metals, and only if they're above it on the list. So Li can kick out anything. Gold cannot kick out anything. And there's one kind of weird one on here. Hydrogen is not actually a metal, but it gets put on that side. It's an exception. Over here we've got all nonmetals. So fluorine is the most powerful nonmetal. Fluorine can kick out any of the nonmetals below it. So let's go back and look at our problem. F is going to try to kick out Cl because they're both nonmetals. So F is going to be able to kick out Cl, and now Li is going to be with F. And everyone always wants to write F2 there because it was F2 here. But if you check charges, you see that they cancel out. So you do not need to put F2. And then Cl is all by itself. But don't forget about Hofbrinkel. Those 7 diatomic elements that always get a 2. They have to be with one of its same kind, so we need a 2 there. And now we're not balanced. We've got F2, so 2F. We've got 2Li and 2Cl, so we need a 2 there. So it goes 2, 1, 2, 1. How about this one? Copper is a metal, so it's going to try and kick out the metal. But if you check on the list, copper is lower on the list than iron. So this one's an easy problem. All we have to do is say no reaction. If I can get my pen to work, here we go. NR. Now this one's 2 things adding to 2 things. People are always looking at the list to see, is it going to kick it out? No, that's only for single replacement reactions. So for double displacement reactions, assume the first 2 things are always going to switch. So Li is now going to be with PO4. And since it's a new relationship, we need to check charges. So this becomes Li3PO4. And now Ca is going to be with Cl. Check charges. It's going to be CaCl2. And now we're not balanced. Li3, Cl2. I'm going to start with the Ca's. Ca3, 3Ca. PO4, 2. So we need 2 to make it 2 PO4s here. Now 2 times 3 is 6. 3 times 2 is 6. So we need a 6 in front of the LiCl. Alright, letter D. One thing breaking down. We've got a decomposition reaction. So just break it apart and then think, is either one of these in Hofbrinkel? And N is, so it gets a 2. Now we need to balance it. N2 on the right side, so we need a 2 here, and that makes 6 NAs. So now we're good. 2, 6, 1. Alright, let's move on to the wordy ones. This one says, write a balanced equation showing the states of matter for the formation of sulfuric acid from water, which you know is a liquid, and sulfur trioxide gas. It forms aqueous H2SO4. So this is it. As long as it's balanced, which it is, we're done. So the only background knowledge that you needed here, it told you everything else other than the formula for water and that it's a liquid. How about 24? Write a reaction showing what happens between hydrochloric acid and calcium. So hydrochloric acid is HCl. That is not something that you need to have memorized for the final, but I'm guessing you've seen it enough that you probably know that, and that acids are dissolved in water, so they're always AQ. Calcium metal, that means it's a solid. The only metal that's a liquid at room temperature, besides gallium, I guess that can be considered that too, is mercury, and calcium is definitely not one of those. So is calcium powerful enough to kick out hydrogen? So you go and you check your list, and you say, okay, here's calcium, hydrogen's way down here, so yep, it is. Now H is by itself, but H is never by itself because it's in Hofbrinkel, so H2 plus, now Ca is with Cl, Ca is a +2, Cl is a -1, so that becomes CaCl2. We're not balanced, we need a 2 out front. And then, states of matter, H2 is a gas, hydrogen, and calcium chloride, that's ionic. So if you've got something that's dissolved in water, and then you've got something ionic, it's going to also dissolve in water. So that gets an AQ. How about number 25? Show the reaction between iron 3 chloride and sodium hydroxide. That means iron's got a +3 charge, chlorine's -1, so this is FeCl3, and sodium hydroxide, that's just NaOH. Those charges cancel out. This is double displacement, so the first two things switch places. Now Na is going to be with Cl, and Fe, which still has the +3 charge, is going to be with OH, which has a -1 charge, so this will be FeOH3. Now this is not balanced. We've got Cl3 here, so we're going to need 3. And now we've got 3 Na, so we need a 3 here, which makes sense. 3 OHs, 3 OHs. Now everybody's happy. All right, number 26. Use the activity series and your knowledge of the relative reactivity of halogens to predict whether or not the reaction will occur. Write the balanced equation for something that does occur. So is Br capable of kicking out Cl? I knew it was Br trying to kick out Cl because they're both on the halogens list. Br is below it. So this makes our life easy because now we do not have to write out the balanced equation, we just get to write Nr. This one though, calcium is higher up on the list than magnesium, so magnesium's kicked to the curb, it's all by itself. And now Ca, which also has a +2 charge, is with the NO3. So this becomes CaNO3 too. Now this is already balanced, so we're good on that one. Now letter C, K is more powerful than hydrogen. You can check your list. So this makes H2 plus, K's got a +1, SO4 is a -2, so this makes K2SO4, which means we're not balanced. We need a 2 out front. Finally, the last one, is zinc powerful enough, to kick out that sodium? It's not. Sodium's higher on the list, so we have another easy one. That just gets an Nr for no reaction.